Hello, I'm Jenny Lynch and welcome to the Creative Science Podcast.
Hi, I'm Matilda and today's show is all about the science of sound. Listen up, because here come 5 fun and fascinating facts about the science of sound. Fact number 1. Sounds are caused by vibrations.
A vibration is a back and forth movement. For us to hear a sound, the back and forth movement needs to happen at least 20 times every second. And we can hear sounds from vibrations that are up to 20,000 times a second. A second is not a very long time, so that's some very fast vibrating.
Fact number 2. Another word for vibrations per second is frequency.
And the unit of measurement for frequency is Hertz, named after German physicist Heinrich Rudolf Hertz, who incidentally spent most of his time studying electromagnetism.
Fact number 3. Sound travels in waves.
We normally hear sound waves after they travel through the gases in air, but sound waves can also travel through solids and liquids. You might have seen waves in water making the water go up and down. Sound waves are a bit different. In a sound wave, atoms or molecules squish together and then move apart as the wave moves through a solid or a liquid or a gas.
Fact number 4. Slower vibrations make lower sounds and faster vibrations make higher sounds.
Lots of animals can hear sounds that us humans can't hear. Big animals like cows and whales can hear sounds that are too low for us to hear. Smaller animals like dogs and cats and mice can hear sounds that are much too high for us to hear.
Fact number 5. The loudest animal in the world is thought to be the sperm whale.
The loudness of a sound is measured in decibels, and a sperm whale has been recorded making a sound of 230 decibels. Compare that to the human voice. It can only make a sound of less than 100 decibels, even when a person is shouting at the top of their voice.
Let's take a deep dive into a type of animal that uses sound waves to find friends. They are small, slimy, and hop around near ponds. Yes, I'm thinking of frogs.
What sound does a frog make? You might be thinking of a ribbit or a croak, and yes, some frogs ribbit and some frogs croak, but there are other frogs that might grunt or bark or even make a bonk sound. There are over 240 different species of frog in Australia, and each species or type of frog has its own call. It's the male or the boy frogs that make sounds to call out to female or girl frogs. A little male frog might make a high sound that can be heard by similar little female frogs. A bigger male frog of a different species might make a lower sound that can be heard by the same type of bigger female frogs. Some male frogs use the science of sound to change their voices. Herpetologists, which are the scientists that study frogs, have found little male frogs using hollow logs to make their voices louder. If a frog sits inside a hollow log while it's making its call, the log will vibrate and amplify the sound by making more air vibrate. If a male frog is making a sound, the female frogs of the same species will hear the sound, but other females won't. The female frog's ears are tuned into the call of the males from their species. Here's a froggy question for you. Do frogs have ears? They don't have a flappy bit on the side of their head like we do, and most frogs don't have an ear canal. Instead, their eardrum is on the surface of their head. The eardrum vibrates and transfers the vibrations into the inner ear and the cochlea, just like in our ears. But frogs have another part of their body that vibrates when they hear a sound. Their lungs vibrate almost as much as their ears do, and scientists think this might have something to do with how frogs make sounds. The lungs vibrate to equalize the pressure inside their ears, so they can make really loud sounds without damaging their ears. Frog science is absolutely riveting, isn't it? You can find out more about frog science from a project called Frog ID at the Australian Museum. Search online for Frog ID, that's FROGID, and you can even get involved in researching frog sounds. Scientists from Frog ID are getting help from people like you to record frog calls using a smartphone app. So hop to it, become a citizen scientist and help out with some unforgettable frog science.
Now it's time for a question. How does my ear work? I know I can hear sound, but how does that happen?
Well, Matilda, when you hear a sound waves are collected by the outer part of the ear, which is called the pinna. The sound waves travel into the hole in your ear, causing the air inside the ear canal to vibrate. The ear canal is a small tube which ends at the eardrum. When the air inside the ear canal vibrates, the eardrum also starts to vibrate. On the other side of the eardrum, the side that's deep inside your skull, there are 3 tiny bones that are each about the size of a grain of rice. These tiny little bones form a chain between the eardrum and the cochlea. We'll get to the cochlea in a minute. These 3 tiny little bones are called the ossicles, and each ossicle has 2 names. There's the name that normal people might use, and then there's the fancy Latin name that doctors use. First, we have the hammer bone or malleus. Secondly, there's the anvil or incus. And thirdly, we have the stirrup bone or the stapes. When the eardrum vibrates, it makes the hammer bone vibrate. The hammer bone passes the vibrations to the anvil bone, and the anvil bone passes the vibrations to the stirrup bone. As the vibrations are passed along the chain of tiny bones, the vibrations become bigger. The stirrup bone is connected to the cochlea, which is a round spiral which looks a bit like a snail shell. The cochlea turns the vibrations into electrical signals that are sent to the brain, and the signals tell the brain if the sound we've heard is high or low, or loud or quiet. So that's how our ear works. But most people have 2 ears, right? And the reason we have 2 ears is so we can tell what direction a sound is coming from. If I hear a sound to the left of my head, my left ear hears the sound slightly before my right ear hears the sound. And the sound will be a bit louder in my left ear than in my right ear.
You can experiment with this for yourself with some help from a friend. Close your eyes and ask your friend to clap their hands. You should be able to point to the direction the sound of the clap was coming from. Try it a few times with your friend changing the position of the clap. Next, block one of your ears and repeat the experiment. You could try using some earmuffs and only covering one ear. You will probably find it much more difficult to point in the direction of the clapping sound when you can only hear with one ear.
How do we know what we know about the science of sound? The science of sound is called acoustics, and it's a branch of physics. For at least 2,000 years, people have been thinking about how sound works. In the 1500s, Galileo Galilei studied vibrations and frequency. In the 1700s, scientists started trying to measure the speed of sound, and this measurement was still being improved even in 1986. By the way, the speed of sound in air is about 331 meters per second, which is pretty fast, but it's nowhere near as fast as the speed of light. If you see someone kicking a football way over at the far end of a football field, you will hear the sound of the kick a fraction of a second after you see it. Over hundreds of years, scientists made discoveries about sound waves, and people started to apply this knowledge to things they were designing and building. For example, architects use the science of acoustics in building design. Understanding the sorts of sounds that human ears can hear also led to discoveries in sound waves that humans can't hear. Infrasonic sounds have frequencies that are less than 20 Hz, which are too low for us to hear. Infrasonic detectors can be used to measure explosions and earthquakes and volcanic eruptions. Ultrasonic sounds have frequencies higher than 20,000 Hz and are too high for us to hear. Ultrasound machines are used in medicine to see inside the human body and can measure blood vessels and muscles and make pictures of a baby before it's born. Animals have been using ultrasonic sounds for a lot longer. Some bats make ultrasonic sounds that can bounce off objects and come back to the bat's ears. If a bat hears a reflected sound, it knows there's an object in the way, so it can fly around it. This animal adaptation is called echolocation, and it's also used by dolphins. As I said earlier, sound waves can travel through solids, liquids, and gases. In fact, they travel much easier through liquids and solids than they do through gases.
You can test this out yourself. Of course, you should tell an adult what you are doing and make sure you get their permission first. You will need a metal spoon and a piece of string, about 30 centimetres long.
Tie one end of the string to the spoon and wrap the other end of the string around one of your pointer fingers. Stand up and put the pointer finger in your ear and lean to the side so the spoon is hanging freely. Now bump the spoon on something hard, like the side of a desk or the back of a chair. What do you hear? This time take your finger out of your ear and bang the spoon on a hard object again. Does it sound any different? When you bang the spoon on something hard, the spoon starts to vibrate to make a sound. The spoon will keep vibrating for a few seconds and it sends sound waves up the string. If the string is in your ear, the sound waves go directly into your ear and you'll hear a loud sound, a bit like a bell ringing. If the sound waves travel through the air instead of the string, the sound will be much quieter and you might not hear the ringing sound at all. To hear how sound travels through a liquid, try running a nice warm bath. Lie down in the bath and tap the sides of the bath with your fingernails. What does it sound like? Next, sink down into the bath until your ears are under the water and tap the sides of the bath with your fingernails again. Do you notice any difference? The sound will be much louder when it travels through the bath water compared to the sound waves passing through air. After that relaxing bath, it's time for me to go. Thanks for listening and remember to stay curious.
The Creative Science Podcast was recorded on the traditional lands of the Bidjigal people. For more information about Creative Science Australia, visit creativescience.com.au.